All right, so let's continue this conversation about we did the whole metal oxide thing. We're gonna go to the other side and do non-metal oxides. These typically, non-metal oxides, tend to be molecular and tend to be either gases, comma, liquids, or low melting point solids, low melting point solids. So think carbon dioxide. So going back over to our periodic table, non-metal oxides, so carbon dioxide, nitrogen oxides, anything over here. We can look at all sorts of different examples. Hydrogen oxides, water. These typically all are going to be either gases or low melting point solids. All right, nice little example. Well, we'll do this part first. When we mix these guys with water, they form not bases, but acids. And easy example, carbon dioxide. You add that to water, maybe you remember this from last year, just stick them all together. You get carbonic acid. And you can do this with a variety of other ones. Here's a really good example. Sulfur oxides, trioxide. Add that with water, and you get sulfuric acid. So non-metal oxides with water will give you an acid. Let me just pull up a slide here really quick. Pull this over. And just looking at the periodic table, this is something in your book. And most that you're probably familiar with, at least going the left to right, or excuse me, in this case, right to left. We know these are all metals over on the left-hand side, and we know the ones on the right-hand side in green are the non-metals. So, okay, metallic character is going to increase going from right side of the table towards the left side of the table. And we kind of see this basically in how they behave in gaining and losing electrons. This is what can kind of contributes to that in how they behave. The part that isn't quite as clear, grab a hold of carbon in column 4A. If you look at carbon and you go down the row, notice that carbon's like, I don't know, that can go either way. It's sort of metalloidish, but you go down to lead at the bottom, tin and lead. Those are definitely metals. So as you can kind of see on the far left-hand side, increasing metallic character going down. So some of these, it wouldn't be at all obvious. If you're looking at lithium to cesium, it's like, I don't know, they're all metals. But the metallic character increases going down any particular column. But just focus on the carbon one. That's the one that I usually grab to get a better understanding of how these things behave. Okay, let's bounce over to our homework problems. And we'll bring that in if I can find them. And I kind of left this for a little bit, so we're going to have to do a little bit of backtracking. That's okay. We'll start with 41. Identify each statement as true or false. If it's false, rewrite it, so that's true. Ionization energies are always negative quantities. So they're exothermic processes, they release energy. And that is false. So think again, ionization energy, that's the energy required to remove a negative electron from an atom that has a positive nucleus. And that is false. Atoms do not like, if you give them a personality, do they not readily release electrons. They have an attraction, so it doesn't happen. So false. According to the definition we talked about a while ago, energy is always required or needed. to remove a negative electron. And again, because it's attracted to a positive nucleus. B, oxygen has a larger first ionization energy than fluorine. So let's look at this first really quick. Oxygen, fluorine. Oxygen always has a larger first ionization energy than fluorine. Well, that should be false. Increasing going across here. And so fluorine is going to have the highest in that row because of Zeph. So we will answer that as false. And the reasoning for that is fluorine. Sorry, I have to keep pausing. My dogs are barking. The reason for that is fluorine has a greater Zeph. And it will require more energy to remove its electrons. Okay. C, the second ionization energy of an atom is always greater than the first ionization. Absolutely. Because you still have the same number of protons, so each subsequent electron that you rip off the atom is more tightly held because of the unbalanced attraction between the positive nucleus and any electron on that outside shell. Right, 64. Arrange the following oxides in order of increasing acidity. So these are all, well, they're not all, metal oxides or non-metal oxides, and we're trying to put them in increasing order of acidity. So the first one we want to do is try to figure out if there's any metals in here or the largest metallish things. And the ones I grabbed right away are calcium and aluminum. Those guys definitely look like metals to me. So which one's the most metallic? All right, calcium, there it is, and there's aluminum. Given this comparison here, calcium is going to be the most metallic, being this far over on the periodic table. And again, metallic character also increases going down, so it's one row lower and further to the left. So definitely calcium oxide. So calcium oxide, and then aluminum oxide, and then who's next, given our list here? We've got silicon, sulfur, and phosphorus. These two guys are definitely going to be non-metals. Silicon is like one of those metalloidy things. So that one is going to be the next one in our listing here. And now the last two, I'm not super thrilled given these two choices here, but knowing who and what they turn into, it's a little bit easier in a comparison. Given what we have here, you're going to end up with something along the lines of phosphoric acid. And if you add, which we already did as an example, water to this, you're going to get sulfuric acid, which is a really strong acid. Based on the periodic table, having these guys with sulfur and phosphorus hanging out here side by side, not too bad. This is definitely more to the right hand side, so it's going to be more on the acidic. But I guess that's okay as far as the example goes. So we'll go P2O5 and SO3. That's our listing for the metal oxides or acidity character. All right, these are really difficult. People generally struggle in these types of problems. Let's see if we can rip on through them. 67. We're just making some equations. So you have barium oxide. Barium oxide, there it is. And you're adding water. So again, this is a metal oxide you're adding to water. You're going to get something basic. And mixing these guys together, the oxygen is going to come over here. It looks like it's going to make hydroxides. And this really just happens to come with experience. So you should do as much work with this as you can to figure it out. So again, what you're seeing here is a metal oxide plus water producing a base. And we've seen this already. Okay, I am going to pause here just because I don't want to try to fill all this in the last lecture. And we'll do one short lecture after this one.